Hello everyone, today let's solve the problem number 3 to 9, longest increasing path in a matrix, right? So what the question states here, we are given an m into n integer matrix. You can clearly see m into n is nothing but rows and columns. We are given an m into n integer matrix and we need to find the length of the longest increasing path in the matrix. So we have to find the length of the longest increasing path in the matrix. In the diagram they have clearly showed here. So in this case, this is the longest increasing. Longest increasing means we have to go in the ascending order of numbers, right? So 1, 2, 6, 9. So this is the longest increasing path. So this will be 1, 2, 3 and 4. The length we have to return. So the output will be 4 in this case. The longest increasing path is 1, 2, 6, 9 they have given. We need to return 4. The length we have to return. So the output is here 4, right? So I hope this is clear. So next, let's see the next example here. So here input they have considered here. Just give me a second. 3, 4, 5, 3 to 6, 2 to 1. Here also you can clearly see 3, 4, 4 to 5, 5 to 6 here. So the length will be in this case 1, 2, 3, 4, right? Sorry, this is not 3, this is 4. This is 3, 4, 5, 6, right? So this is 1, 2, 3, 4. So totally, so overall the output has to be 4. This is length, right? It starts from 1, it doesn't start from 0, so I got confused here. The output will be 4 in this case. I hope this is completely clear. The third example here is we have only one element within the matrix, so output will be quite obviously 1, right? So I hope the question is completely clear what we need to do here, right? So first let's discuss the approach followed by edge cases one by one, and then finally write the code and discuss the complexities of the code that we have written. As usual, first let's discuss the approach step by step. So the approach that we'll be going with for this particular problem is memoized DFS or DP with the DFS, dynamic programming with a depth first search, right? So first thing here is we will define a DFS function, right? Initially we have to define the recursive DFS function. The further things we will discuss while writing the code itself, right? So the second step here is apply DFS on each cell here. So either when we are applying DFS, either we can move up, we can move down, we can move right, or we can move left left one step at a time, right? So we are going with the DFS, apply DFS on each cell, right? So we will traverse every cell in the matrix and call the DFS on each of them. So the DFS function explores 4 possible directions. One is up, down, left and right. This one we have to keep in mind. Third step is here memoization. So to avoid recalculation in each cell, so we will be making use of the dynamic programming, nothing but memoization. We use DP table. We'll be making use of DP table, right? Just to store the longest increasing path from each cell I comma j in this case, right? So if DP of ij, as we are going with the DP table, 2D DP table, if DP of ij has already been computed, then we will return the stored value instead of recomputing it. This is important thing. So this ensures that each cell is visited only once, optimizing the time complexity, right? So I hope this is completely clear. So if we go with this one, instead of memoization, if we go with the redundant calculations or calculating again and again, if you go with the redundant calculations, then it will be, the time complexity would be big O of 4 to the power of m into n. So instead, if we avoid this one and if we use DP here, the overall time complexity would be big O of m into n, right? M is nothing but number of this one rows and n is nothing but the columns here in this case. So this is one advantage of using the DP with the DFS for this particular problem. So let's see how we are calculating here. So first we will start the DFS for each cell. So suppose we are starting the DFS from the cell this one 2 comma 1. In this case we have 9 comma 9 9 4. Let me write here 6 6 8 here in this case 2 1 1, right? So we will start DFS at 2 comma 1 first. So this one 2 comma 1 first, then what we will do, we will move to 2 comma 0 here, this one, right? So then from we can move one step left, one step right, one step up, and one step down, right, when we apply DFS. So next what we will do, we will apply DFS and we will move to 1 comma 0. So this will be 1, 2, 6, and finally we can move one step, this one, up, right? It will be 9. We can move right as well, but here the value is 6. We already have this one, right? So the highest value will be 9 in this case. Highest increasing value will be 9 in this case. So 1, 2, 6, 9 here, right? So here also we can move, but we already have one value, so we have to go for the highest value. This we will ignore, this also we will ignore. When we move to the next one, so here we cannot, we already have the value 9, right? It should be greater, so this also we will ignore in this case. This will be 1, 2, 6, and 9. In this case it will be 4, the length will be 4, right? So this is the approach that we will be going with by making use of memoized DFS. I hope the approach is completely clear. Next what we will do, let's discuss the edge cases one. So the first edge case that we are going with here is minimum matrix size. We have only one element here, so output will be in this case 1, right? So we'll just move one step. If you are applying DFS, output will be 1 in this case. Sorry. So here also I have given anyone you consider this one. So this is fine. So the second edge case will be all elements same. Well, all the elements are same. Output will be this one, 1 as well here. Every number is same, so there is no increasing path here, no increasing path at all, right? So every element is same if you move anywhere, if you start from anywhere. So the output will be 1 in this case. So let's move on with the third edge case here. We'll be considering already sorted increasing matrix. So here matrix I have considered already sorted, means 1, 2, 3, 4, 5, 6, 7, 8, 9. So we are moving from here, this one to this one, this one to this one, and here will be again 4, 5, 6, this one, 7, 8, 9. So here output will be 9 in this case, right? So this is one thing. Just give me a second. Yeah, output will be 9 in this case. So we can move in a sorted manner, getting max path of 9 in this case. So completely decreasing matrix. In this case, output will be 1, right? So no, here because no move increases the value, we have the decreasing matrix, right? No move will increase the value, the path length remains 1 itself in this case for the completely decreasing matrix. These are the edge cases that we need to consider here. The first edge case was for minimum matrix size, the second edge case was for all elements same, the third edge case was for already sorted increasing matrix, and the fourth edge case was for completely decreasing matrix, right? So I hope all the edge cases along with the approach is completely clear. Next what we'll do, let's start writing the. So the first thing we'll be doing here is we'll be making use of the length of the matrix, right? Both rows and columns. We'll be making use of length of rows and columns. So here in this case matrix, right? So I'll just give here, let me initialize m2 or assign m2 matrix dot length, this one columns n equals matrix of, let me give here 0 dot length in this case. This is fine. So the next step here is we will initialize the DP table to store the longest increasing path from each cell. We have discussed this one and we should be knowing this one. Just to avoid the redundant calculations, we are going with the memoization or the DP table. So we'll be going with 2D DP table here. So we know this one. So let me write here. So we are just articulating the approach or the thought process that we discussed in the approach, right? That we are articulating in the form of code here. So this will be array of m dot fill. So let's make use of map as we are dealing with this 2D DP, right? So here this will be array of m and n rows and columns, right? So here this will, let's fill this one columns with initially 0. So I hope this is completely clear, right? So the next step here is let's go with the DFS, right? DFS function with memoization. So here let me give const DFS function here, parameters I, J and previous I'll go with. So this is fine. So DFS, this is fine. This is just the DFS function, or you can just call this one recursive DFS function. This was the first step we discussed. But during the uh, while we discussed the approach, the first step was I said that we'll be going with the recursive DFS, right? This is the recursive DFS. Within the DFS function, what we'll be doing first thing, boundary conditions. Boundary conditions, if out of bounds or value is not increasing, at that point of time we have to return 0, right? Simple if condition, let's go with here I less than 0 or I greater than or equal to m or j less than 0 or j greater than or equal to n or matrix of I, here this one will be j less than or equal to previous, then what we will do, we have to return 0 in that case, right? So I hope this is clear. This is simple if condition. Next, if already computed, then we have to return the stored result. So if you have already computed, we have to obviously return the stored result, right? So this we have went with a 2D DP. So I'll just consider here DP of ij. If DP of ij means if already computed, then we have to return stored result. Nothing but return DP of ij itself. This is fine. I hope this is clear till here. The next step is we have to store the current cell value, right? Current cell value, whatever we compute, so we have to store it somewhere. So I'll just make use of the variable v and let's store the current cell value. This will be matrix of I and j. I hope this is clear. So the next step after storing the current cell value, we have to recursively explore all the 4 directions and we have to store the maximum path. That's what they have asked in the question as well, right? So let's go with the recursion now. So I'll just give here return 2ddp. So this is a bit confusing when I make use of the 2ddp. So this will be dp of ij. Here it will be 1 plus as it is 0 index, right? So I will just give you 1 plus in this case. So we need the max here, max length we need, right? So we'll be going with the mat.max here in this case. So we need to explore all the 4 directions here by making use of the recursive function here. Let me copy this one in this case, dfs function name. Let me paste here dfs of I plus 1. So down, up, right and left. Here I'll just give I plus 1 j comma v. This is for the down. Let me copy the same thing here. Let me paste 3 times here and let me make the necessary changes here. This will be I minus 1 j and v. So the next one will be I comma j plus 1. So let me give here, just give me a second here. I comma j plus 1. This is fine. I comma j plus 1 comma v I have given here. This is for the right and then finally left. So I'll just go with the j minus 1 this time. So let me come here. This will be j minus 1 and v. So let me remove the comma here for this one. So this is fine. I hope this is clear. We are just recursively exploring all the 4 directions and we are just storing the max path here, right? Hope this is completely clear. The next step here is, next step or the final step here is, we have to compute the longest increasing path starting from every cell. So I'll just give here, we need maximum value. So I'll just go with the mat.max here. So let me give here h. Just give me a second here in this case. Mat.max of, so let's go with the spread operator here. So spread operator matrix dot, let's make use of the flat map. so that we get the output within the as a single number, right? So that is the reason we'll be going with the flat map in this case. So flat map of, so any variable we can go here. In this case, let me go with the underscore. This is of no use, so I'll just go with the underscore comma I here. So this will be matrix of I. This is fine. Matrix of I dot map here. This one again. We went with I. We have to go with J as well. Rows and columns. So I comma J. This is fine. The next step is we have to go with the DFS, right? So DFS here. Let me give here. So let me leave space here. Just give me a second here. 1 second. This will be DFS I J, starting from I J to infinity, negative infinity. So I hope this is completely clear, right? So this is it for the code. We are just computing the longest increasing path starting from every cell. That reason we are making use of here spread operator, flat map, and finally within the map what we have to go with I and j. We are starting with I and j right here. So I and j and to minus infinity. So that's what we are doing here. So I hope this is completely clear. Let me format this one once and let me hit the run button. So one arrow function parameter list here. Why this is wrong? Just give me a second here. Let's see where we have done wrong. So yeah, in this case it should have been just give me a second here. So yeah, we have to make one more this one here, one more bracket. So let me run this one again. I hope this works again. I hope this works. Yeah, you can clearly see the sample test cases are getting passed here. So let me hit the submit button. Let's see. I hope this works for all the test cases. So yeah, you can clearly see the sample test cases are getting passed here. So the code works absolutely correct in this case. Let's quickly discuss the time complexity or the complexities of the code, complexities for the code that we have written. So the approach that we went with here is DP with DFS or memoized DFS, we can say, right, in simple terms. So overall time complexity would be here big O of m into n. So we are avoiding the redundant calculations by making use of memoization or the DP. By making use of DP, we are avoiding the redundant calculations. If we wouldn't have made use of DP, if we were going with the redundant calculations, then time complexity would have been big O of 4 to the power of m into n. So we are decreasing the time complexity from big O of 4 to the power of m into n to big O of m into n in this case, right? So that is the main advantage of using the DP here. We are making use of 2D DP table, right? So this is fine. So what would be the space complexity here? The space complexity would be big O of m into n as well in this case. So why the time complexity here is big O of m into n? Because we are visiting the each cell exactly once and results are stored using the memoization. So no redundant computations occur here. So the time complexity would be big O of m into n. So why is space complexity m into n as well here? Because we are making use of DP array. Here you can clearly see DP array. DP of ij. Nothing but DP of ij. This stores the results for each cell. So recursion depth is at most m into n in this case, right? So that is the reason overall space complexity here is big of m into n. The time complexity and the space complexity for the code that we have written is big of m into n. I hope the solution that we have written is completely clear. For now, this is it. Thanks for watching, guys.